Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is soup serving. The problem category is of medium level, and I would say yes, it is a medium level of problem. But after watching this video, understanding the problem and the solution approach, you are going to find it easy to solve. Now, the given input in the problem is an integer which is called n. So we are just given one input, an integer n. The output we need to find is the probability that A is used before B. I will tell you what is A, what is B. But as of now, you have to assume that you know about A, you know about B. Then the output you need to find is the probability that A is used before B plus the probability that both soups A and B is used at the same time will be half. So our focus is to find what probability is that A is used before B, and if A and B are used at the same time, the probability is going to be 1 by 2. That's what the question says. The question also says that our answer, which is basically the probability, and you should know a very important fact that the probability can be between 0 to 1. This is a universal fact. This is a mathematical fact. So the value of probability have a range of 0 to 1. If no probability is there, then 0. If full probability is there, then it is 1. So our answer, that is the probability, can have an error up to 10 is to power minus 5. That is, if the probability we want to find is equal to 0.99999, then we can call it as 1, because the difference between 0.99999 and 1 is about 10 is to power minus 5. And the question says that an answer with an error of 10 to the power minus 5 are accepted. Now this is going to be a very important information for us when we are actually solving the problem. Now let us try to understand what's given to us in the problem. Basically what's given is we are given two soups. So you can assume that you have a drum, you have a cup, you have a glass, anything you can assume. So you are basically given two soups A and B in a cup, drum or a glass, and the capacity of A and B is equal to n. This n is given in the input. So we are given an input n, and it is basically representing the capacity of the soups A and soup B. So we are given two soups A and B. Now there are four events which could happen at every turn. So basically something is happening at every turn, and what are the events which could happen are, we can take out 100 from A and 0 from B. Basically A and B are soups, right, which have the capacity of n. So we can take out something, we can take out some part of soup A or soup B at every event, and there are just four events which could happen. The four events which could happen at every turn are, we can take out 100 from A and 0 from B. This is one of the event which could happen. Or we can take out 75 from A and 25 from B. That's another event which could happen. We can take out 50 from A and 50 from B, and we can take out 25 from A and 75 from B. These are the four events which could happen at any turn. So basically there is a process which is going on, and that process is happening in turns, and the process is going to stop after any of the A or B soups are empty. So the soups have a capacity of n, but we are having some events which are happening, and after every event some part of A or some part of B is going to be reduced, right, because we are taking out some part of A and some part of B. So the process is going to stop after any of the A or B soups are empty, that is, it is less than equal to 0. Basically it can be 0, it will not be less than 0. Now the probability of these events happening are equal. The probability is going to be 1 by 4, because we have total 4 events. So we have 4 here, and one out of the 4 event can happen at any turn. So the total probability of any event happening is equal to 1 by 4, which is equal to 0.25. Now after we know these things, what we need to do is we need to find out the probability that A is used before B. Basically we need to start our process of taking out 100 from A and 0 from B, or taking out 50 from A and 50 from B. Basically any event could happen, but you will notice that after some time, when the process will stop, it will only stop after A or B soups are empty. We just need to find out the probability that A is going to be used up or A is going to be empty before B. If A and B are empty at the same time, the probability is going to be half, that is 1 by 2, which is equal to 0.5. Now based on the given facts, you will have to understand a very important fact here, that the four events which are happening, in those four events, every time something is getting reduced from A, can be 100, 75, 50 or 25. But for B, we just have three chances or three events when the capacity of B is going to be reduced. That is one event when the capacity of B is not going to be reduced, right? It is 0, 25, 50 and 75. So from here we can understand that the probability of A going to be empty is much more than probability of B going to be empty, right? Because all the events are supporting A, right? In all the events A is getting reduced, but not in all the events B is going to be reduced. So if we talk about four different events happening, and if we say that since the probability of these four events happening are same, and let us say in the four events which has happened, all these four events take place one time. So you will see that total capacity of A reduced is equal to 100 plus 75 plus 50 plus 25, which is equal to 250. So when four turns are completed, 250 capacity of A is reduced, but for B it is 25 plus 50 plus 75, which is equal to 150. So the chances of A going empty is much more than chances of B going empty. Now let us try to understand this with an example. Let us say the value of n is equal to 50. It means the capacity of A is equal to 50 and the capacity of B is equal to 50. This is the initial data we have. There are 4 events which could happen and we don't know which event will happen. So we will try with all the 4 events. The first event is A is 100 used and B is 0 used. Now, since the capacity of A is 50 and you want to use 100, so basically the question says that if you want to use 100 or more than the available capacity, you can put it as 0. Basically, the remaining capacity you can use. So if A is 50, B is 50, and this event happens, then A will be 0, B will be 50. At this point, you have to understand that the probability of A getting consumed fully is 1, right? That's the highest probability. It means it will definitely happen. But what if this event doesn't happen, but the second event happens in which A is consumed 75, B is consumed 25. So we have A as 50, B as 50. After this event happens, A will be 0, B will be 25. And the probability that A is consumed is 1 again, because A is consumed, right? Now, if both are 50 and this event happens in which we are going to consume A as 50 and B as 50, in this case, A will be 0, B will be 0. A and B both are used at the same time. So in this case, the question says that the probability of this will be 0.5, that is half. And what if the fourth event happens? In this case, A will be 25, B will be 0, because the capacity of A used is 25, the capacity of B used is 75, B is 50. You want to use 75. Since the capacity is less, all the capacity will be used and it will be reduced to 0. In this case, A is going to be 0, will be 0. The probability is going to be 0. Reason being, B is already consumed and we have to stop here. Anytime when B or A goes to 0, we have to stop. So after we have checked for all the 4 events, the probabilities are 1, 1, 0.5 and 0. Now we have tried with all the 4 events. The actual probability of all the 4 events happening will be the sum of these 4 probabilities divided by 4, right? Basically, you got 4 probabilities with you and we don't know which is going to happen. So the actual probability is going to be the sum of all these probabilities divided by 4. That is the total number of events. This is basic mathematics for probability. So 1 plus 1 plus 0.5 plus 0 will be equal to 2.5 divided by 4. It will be equal to 0.625. This is going to be our final answer for n is equal to 50, because our process has stopped anytime any event happens, right? Because either A is going to be 0 or B is going to be 0. So for n equal to 50, the probability that A will be equal to 0, that is the capacity of A will be fully used, will be equal to 0.625. Let us see one more scenario in which A is equal to 100 and B is equal to 100. That is n is equal to 100. In this case, again 4 events can happen, right? Either A will be 100 and B will be 0 used, or A will be 75 and B will be 25 used, or A and B both will be 50 used, or A will be 25 and B will be 75 used. When the first event happens, A will become 0, B will be still 100. In this case, the probability that A is consumed fully is 1, right? Because A is fully used after one event. So definitely if this event happens, the probability of A going to be consumed fully is 1. That is full probability. It will definitely happen. If the second event happens, in this case, A will be left as 25, B will be left as 75. So in this case, we have to do the operation again. We have to do one more turn. So we will process it later on. But now let's see the third event, which is A is used 50, B is used 50. In this case, both A and B remaining is equal to 50. We have already calculated in the previous scenario in the first input that if A and B both are 50, then the probability that A will be fully used first will be equal to 0.625. So I can start calculating it, but since we have already calculated it, let's assume that the value is 0.625. Now let us try to process for 25 and 75. After this event has happened where A is used 75, B is used 25, A will be left as 25, B will be left as 75. We still don't know the answer in this case, so we will do the event again. Now if the first event happens, then A will be used 100, B will be used 0, right? So when you take out 100 from 25, it will be 0, and when you take out 0 from 75, it will still be 75. So I think this will be 75 and not 0. So we will be having A as 0 and B as 75. In this case, you can see that the probability of A going to be 0 will be 1. If this second event happens, that is if we have A as 25, B as 75, and this event happens, then A will be 0 and B will be 50. Again, A is reduced to 0, so the probability is 1. If the third event happens, which is A is used 50, B is used 50, then this will be reduced to 0 and 25, A and B respectively. Again, you can see A is 0, so the probability of A consumed fully is 1. But if the fourth event happens, that is 25 and 75 are used, we have 25 and 75 as the capacities, so it will be reduced to 0 and 0. In this case, you can see that both are reduced to 0, so the probability will be that A is fully consumed is 0.5. Again, if I try to calculate that, if this is my original scenario where A is 25, B is 75, then the probability that A is consumed first will be 1 plus 1 plus 1 plus 0.5 divided by 4, which is equal to 3.5 divided by 4, which is equal to 0.875. With this particular answer, we will return back, and for this, we will have the answer as 0.875. Similarly, when we will calculate the probability of A being used first when A is 75 and B is equal to 25, the probability is going to be 0.375. This particular way of solving the question screams about dynamic programming, because we have a problem, we are dividing our problems in sub problems, and then we are trying to solve our sub problems again, and we are utilizing the answers from our sub problems, right? So it is all about solving the problem in a dynamic programming way. We basically have a given capacity, we will try with all the four options, and based on all the four options we will keep calculating our answers till we have A as 0 or B as 0 or both A and B as 0. So I would say let's jump back to the code editor and I will try to explain you the solution for this particular problem, and you will be able to understand it, because it is a very straightforward solution. You have a problem where n is equal to 100. You are trying all the four probabilities. If any time your capacity of A or B is equal to 0, you will stop there. But if the capacity of A and B is not equal to 0, you will continue. So now let me jump back to the code editor and try to explain you the solution approach. See, the thing is, first of all, what we are doing is, since we know that we have four operations and the operations are reducing either 100 or 0 or 75 or 25 or 50 or 25 or 75 capacities, right? So you can see that the capacities which are getting reduced are in the multiple of 25. We can say that, let us assume that 25 is equal to 1 unit, 50 is equal to 2 unit, 75 is equal to 3 unit, 100 will be equal to 4 units. Basically, we are trying to say that 25 will be equal to 1 unit. This way, what we can do is we can actually reduce the size of our input. If it is equal to 50, we can assume that the total unit are 2. A is equal to 2 and B is equal to 2. This way, the size of our input will be reduced. We have a input size given as n can be as large as 10 is to power 9, but we are reducing it by 25 times. So we can say that A is equal to, so let me delete this thing. And now we can say that A is equal to n by 25, but we will take the ceiling value of this. For example, if the value of n is equal to 124, so in this case, we can reduce 25, then 25, then 25, then 25, then 24. So basically, we need to do the operation 5 times, right? So we are assuming that instead of decreasing 25, 25, 25 or 25, basically we can reduce 100 by saying that we are reducing 25 4 times. So we can say that let's assume that 25 is 1 unit, and we can say that 124 is equal to 5 units, because we have to reduce it by our unit 5 times, right? So that is why we are dividing n with 25 and taking the ceiling value of it. Similarly for B. Now what we can do is, let us assume that we have a function dp, which is going to calculate a scenario that if you pass it two values I and j, I is the capacity of A, J is the capacity of B, then this function is going to calculate what is the probability that A is going to be used first. That is, I will be equal to 0 first. So we are going to calculate it using this function. I will explain you the function, but first of all, you need to understand this for loop. We are running a loop in our range from 1 to A plus 1. That is, we are basically running our loop from 1 to A, basically from 1 to our whole capacity we have. And we will try to calculate that if the dp of I comma I, that is when the capacity of A and when the capacity of B is equal to 1 comma 1, what is the probability that A will be used first? If this probability is more than equal to 0.99999, then we will return 1. And the reason is, we can return our answer with an error of 10 is to power minus 5. So 0.99999 actually means it is equal to 1. So we are first going to calculate our answers for all the possible values till the capacity of A and B. 1, 1, 2, 2. For example, if the capacity is 50, or let us say the capacity is 100. So it will be first converted into the units. The units will be 4 and 4, right? A will be equal to 4, B will be equal to 4. We actually need to know the answer for 4, 4, right? That is, if the capacity of A is 4, capacity of B is 4, then what is the probability that A will be reduced to 0 first? See, the thing is, for lower values, when the values are less, that is when the values are 100 or 50, the probabilities will not be very close to 0.99999. But what you can notice here is, as the input size is increasing, the probabilities are actually increasing, right? The probability that A will be used first is increasing. And the reason is, according to the operations, A is used more as compared to B. So for bigger values, for values where n will be equal to around 5000, the probabilities will always be 0.99999 or more than that. So we don't need to calculate it further. We can directly return 1 in that case. But if the values are not around this particular range, then we will calculate it again by returning dp of A comma B. So what we are doing is, we are just running a loop in the range of 1 to A plus 1, and we are checking for all the possible values. Is any probability more than this value? If yes, we can directly return 1. If not, let's call the dp function again with A comma B, the original capacities. Now let me try to explain you the original dp function. In this, we are given an I and j. These are the original capacities of A and B. If the I is less than equal to 0 and j is also less than equal to 0, it means that both are reduced to 0. So we can directly return 0.5, right? That's the probability if both are 0 at the same time. But if not, we will check another condition, that if I is less than 0, that is has gone to 0, B is still not 0, so the probability is 1, right? But if j is reduced to 0, I is not 0, then the probability that I will be 0 will be 0. Reason being, if j is less than equal to 0, then b has been reduced to 0, so we can stop. So at this point, the probability that a will become 0 is 0. But if none of the case are true, then we will check that if I comma j is already in our data. Now this is a memoization part of dynamic programming where we store the solutions for our sub problems. If we have already calculated for I comma j and we have stored it in our data, if this value is already in our data, basically data is the dictionary, then we can directly return our value from the dictionary, that the probability that a has a capacity of I, b has a capacity of j, and a getting reduced to 0 will be stored in the data. We will return it from here. But if it is not in the data, then we will store it in the data for the current set of I comma j. We will say that data of I comma j is equal to 0.25 multiplied by 4 different dp functions calls again. Here what we are doing is, we are just performing our 4 operations. That is, if we are reducing a by 100, it means we are reducing a by 4 units and reducing b by 0 units. So we are calling the dp function again with I minus 4 and j. Then we will call the dp function again with the second event I minus 3 and j minus 1, basically 75 units from a and 25 units from b. Similarly, I minus 2 and j minus 2 and I minus 1 and j minus 3. We are performing these 4 operations and adding all the 4 probabilities. Since the probability of happening of any of these events are 1 by 4, we are multiplying the whole probability by 0.25. And then finally we can return the value of data of I comma j. Now this is going to solve our complete problem. We can submit this and this is going to pass all the test cases for this particular problem. But the runtime is not really good. The memory used is not really good. And the reason is there is a lot of dp function calls. And based on the calculations, what we have found is for the values where n is more than 5000, we always return 1. If the values are less than 5000, then we are not returning 1. Then we are doing the calculation using dp function. But if the values are more than 5000, then we are returning 1. So what we can basically do is we can get rid of this for loop and we can have an initial call where we can say that if the value of n is more than 5000, then you can directly return 1.0. If you will submit this, you will find that this is actually very efficient solution for this particular problem. You can see that the runtime has improved, the memory used is improved as well, right? So we have solved this particular problem in a very, very efficient manner. So that's it for this video, guys. If this video helps you to understand the problem, and understanding the problem was the main part. If you understand the problem and you know that why dynamic programming is used, you can apply it very easily. So if this video helps you in any way, then make sure that you hit that like button. And if you're not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.